Assalamualaikum warahmatullahi wabarakatuh, and a very good day to Dr. Fariza and to all who watch this video. My name is NURIN RAIHAH binti Muhammad BOHARI, and my partner name is...
My name is FARAIDA binti ABDULLAH.
In this video, we will discuss or we will explain about Newton's second law.
Definition of Newton's second law. Newton's second law states that the acceleration of an object depends upon two variables: the net force acting on the object and the mass of the object. The acceleration of the body is directly proportional to the net force acting on the body and inversely proportional to the mass of the body. This means that as the force acting upon an object is increased, the acceleration of the object is increased. Likewise, as the mass of an object is increased, the acceleration of the object is decreased. From definition, it is expressed in equation form as acceleration equal to net force divided by mass. The above equation can be rearranged to a familiar form as force equal to mass multiplied with acceleration. Since force is a vector, Newton's second law can be written as the direction of the total acceleration vector points in the same direction as the net force vector. What is net force? A net force is the sum of all force acting on a body. More precisely, it is the vector sum of all force acting on a body. This is the unit SI that used for Newton's second law.
Next, I will explain about the deriving Newton's second law. For changing mass, let us assume that we have a car at point 0, defined by location x0 and time t0. The car has mass m0 and travel with a velocity v0. After being subjected to a force, the car moved to point 1, which is defined by location x1 and time t1. The mass and velocity of the car change during the travels to values m1 and v1. Newton's second law helps us to determine the new values of m1 and v1 if we know the value of the acting force. Taking the difference between point 1 and point 0, we get an equation for the force acting on the cars as follows. Next, for constant mass. For a constant mass, Newton's second law can be equated as follows. We know the acceleration is defined as the change in velocity divided by the change in time. Next, I will explain the application of Newton's second law. The first example is pushing a shopping cart. Pushing an empty shopping cart is easier than pushing a loaded shopping cart. This is because of the relation between the mass of the object, the force applied to it, and the acceleration produced. Since mass has an inverse relationship with acceleration, the loaded cart tends to move at a slower pace than an empty cart. The second example is hitting a ball. A ball develops a certain amount of acceleration after being hit. The acceleration with which the ball moves is directly proportional to the force applied to it. This means that the stronger you hit the ball, the stronger the force we put on it, the faster it will move and further away it will travel, thereby demonstrating Newton's second law of motion in daily life. The last part for this presentation is the example on calculation by using Newton's second law. The example that we stated here is forces in cycling. Newton's second law relates to the sport of cycling for the reason that the cyclist produces an applied force upon the bicycle, which allows the cyclist on the bicycle to enter motion. Next, find the net force of the cyclist given mass of the cyclist and the acceleration of the bike going east. First, we have to draw a body diagram so we know the force direction. They give the mass is 83 kg. The acceleration is 1.366 meter per second squared. Then, they require the net force of the cyclist. As we know, the equation is net force is equal to mass times with acceleration. Then, we insert all the information given into the equation. We find out that the net force for the cyclist is 113.37 Newton. That's all from our group. Thank you and have a nice day.